now. So welcome to lesson 2 of the refresher course. Today we're going to continue on about like what we were doing yesterday, but we're going to put it into a little bit more context. Okay. So what do I mean by that? So we're going to solve some quadratics. We're also going to look at the quadratic formula, and we're going to start drawing some graphs. And what this will do is it'll take what we kind of did yesterday, which is sort of just algebra stuff, right? Like factorization and things like that. And it's going to start linking it into things like functions, like when we get into kind of graphing and stuff. So it's in some way, this is like an application of like what you were doing, like, yesterday, right? So it's sort of getting to sort of resemble something you might think about when you do maths, like making graphs and things like that. And then we can start to think about some sort of usefulness like of this stuff, right? Okay, so yeah, okay, so let's start with a little kind of warm-up type question. So yesterday we were factorizing expressions like this. So we'd have this expression here, x squared minus 5x plus 6. And then, well, what did we do? We factorize it. So we had two sets of brackets, right? This is how we handle these trinomial examples, right? We have an x and an x here, and then two numbers that multiply to give us 6. So it could be 1 and 6 or 2 and 3. Now, they may not be whole numbers. They may not be whole numbers, in which case this method is not going to work. We're going to have to use a different method. We're going to talk about that later, okay? But if we're going to use this method, they have to be whole numbers. So what are the whole numbers that could work to multiply to give us 6? Well, it could be 1 and 6 or 6 and 1, 2 and 3, or 3 and 2. And importantly here, it's a plus here, right? So it's a plus 6. So minus 1 and minus 6 also work. Minus 2 and minus 3 also work, okay? And whatever the two factors that we get, they have to add to be equal to, they have to add to be equal to minus 5, right? So which one example is it? Ends up being 2, and it ends up being 3, and it ends up being minus, and it ends up being minus, okay? So that's just what we did yesterday. Now, if we look over here, we're being asked, what are the roots? So this is what we're talking about now. And when we talk about roots, we're going to get into something called like solve. It is possible to get lost in this terminology, but like the best way to not get lost in terminology, which is the names that we're using to describe things, is to sort of see them in action and see what it's doing. And you're like, oh, okay, that's what they mean when they mean solve. That's what they mean when they mean roots. Okay, so let's not get put off by terminology. Solve will just mean we have to get down to x equals something. You're kind of used to x is equal to one thing, perhaps, maybe, from how you began maths in the first place. In this case, with quadratics, with this square here, we're going to have two things that x is equal to. We'll graph this in a moment, and we'll see how this makes sense. That will be solve. And we can only solve this if we have this left-hand side here, right? So if we have this equal to 0 part, so this is now equal to 0, and this is equal to 0. Okay, so almost there with, I'm doing this slowly, it's warm up, but I always find that if you just take that time at the start, you know what I mean, just to know like exactly what's going on, then everything else afterwards is much easier. So it's a case of slow down, go further, right? Especially at the start. Okay, so we have a set of brackets multiplied by a set of brackets, which is giving us a 0. So that's a number. Remember, we put brackets around something. It's a number multiplied by another number equal to 0. This is only possible if the first thing is 0 or if the second thing is equal to 0. In other words, x minus 2 is equal to 0 or x minus 3 is equal to 0. And now this here, this is like, imagine this was just a question. Well, this would now give us x is equal to 2, and this would give us that x is equal to 3. Okay? Okay, great. So x is equal to 2 and x is equal to 3. So this is the answer here. That's the answer. So these are the roots. Okay, it's also the solution as well. That's what we mean by solve this. Okay, so yesterday we had this piece, which was just factorize it. There was no solving. There was just sort of rewriting this in a way that's breaking it down into smaller pieces. Today, what we have is this additional part, which puts the whole lot into an equation, and that allows us to do things like solve or find the roots, which is the same thing. Now, let's quickly think about what we actually mean by this. I think that's so what do we actually mean by finding the roots? So we're going to take that example that we had from the previous page. Let's say, let's just use this terminology here now. F of x is equal to x squared minus 5x plus 6, okay? And so we've written this as a function, which is our number machine. And what I'm going to do is do the painstaking process of working out the following things. Okay, and I'm going to do it super fast just to sort of, so that we don't, f of 5, so we don't get too bored, right? I'll just do this as fast as I can, okay? So what we're going to do is we're going to take the number that we've subbed in. This is function notation now, okay? So we're going to take that number and we're going to sub it in, which means put it into the formula, put it into our expression here on the left-hand side in place of x. So a 0 in place of x is 0 squared minus 5 times 0 plus 6 is 6. A 1 is a 1 squared, which is 1 minus 5 is then, that'll be a 1 squared minus 5 will be 1 minus 5 will be minus 4, plus 6 will be a plus 2. A 2, when it goes in, will be a 4, a minus, sorry, this will be 4, then minus 10 plus 6, so 4 plus 6 is 10, minus 10, this will be 0. Then 3 squared will be equal to 9 minus 15 plus 6, so 9 plus 6 will be 15, 15 minus 15 will be 0. And, you know, long story short, these are always symmetric, so this will be 2 and this will be 6. Okay, so what I'm going to do now is for each of these, I'm going to write down the input 0 and the output 6. The input 2, the input 1 and the output 2. The input 2 and the output 0. The input 3 and the output 0. The input 4 and the output 2. And the input 5 and the output 6. Okay, so what am I doing? I have a function. I'm putting, the function is just sort of a number machine. You put a number in, you get a number out, okay? And what we're going to do is we have basically, we're going to write down the pairs as input number, output number. Now, what I'm going to decide to do now is represent this set of numbers on a number line, okay? So let me just take them over to the next page. Now, I know that you're familiar with all this, but I just sort of want to say this in a kind of a, just to give as much context as possible, because often we just don't get things because we just don't have enough context. So what I'm going to do now is I'm going to draw, do this, can't I? I'm going to draw, where is it? A number line this way, and I'm going to draw a number line this way. Okay, and then onto the number line, I'm going to put on, what do we have? We have 0 here, 1, 2, 3, 4, 5. Could have done that better, but whatever. 1, 2, 3, 4, 5, and 6. Okay, so I'm going to say, let's have a look at these. These are all the input numbers, okay? And we're going to input these input numbers, and we're going to call that the x-axis, right? The x numbers. These are the input numbers. And we can put all these numbers down like that. There they are, 0, 1, 2, 3, 4, 5. So we put them down on our list. And then we're going to take these ones here. The output number is 6, 2, 0, 0, 2, like this. So we have 6, 2, 0, 2, back 0, 0, 2, and 6 back out again. And the way we've represented these sort of like on separate number lines, what we can do is we can put them out here, and then we can put a point. So we have our first point, use a different color now. Let's say we have our first point, which is up here. and that's the point with the 0 input and the 6 output. And the next one is 1 and 2, so that's the 1 and 2, and this is the 2 and 0, and this is the 3 and 0, and this is the 4 and, sorry, that's the 3, sorry, this is the 3 and 0, and this is the 4 and 2, and this is the 5 and 6 up there. Okay, and now what we haven't done is we put in 0, 1, 2, but we could have put in all the numbers in between 0 and 1, and all the numbers between 1 and 2. We could have put in all of the numbers, gotten so many points that actually had made a continuous type of line. So then let me just sort of draw that kind of quickly. I think I have a tool here to help me do that. So let's try to do it now. I won't use that tool. That tool confuses me. So we have something like, this will be a little badly drawn, but nonetheless. To do. And this we understand to be a parabola. So what is this now? So we had this original function here. We had this function here to begin with. And we put in a few points, input numbers went in, output numbers then came out. And we were able to actually just put those numbers down and then make a drawing of the same. So we could have this, algebraic thing that would show the function, but we have this drawing, which is another way to sort of represent the function. Okay. And what we've been talking about here is this special thing which we've been calling roots. So the roots of a function will be where it crosses the x-axis. It's a little bit arbitrary, like why do we kind of care about it? What we really care about is it crossing some line at some point, right? Like we might say we care about this line here. When is it? What values of x give us this value of y, right? Like so. Let's have an example here. Let's imagine for a second that this thing here this is a function. We're going to use it in the real world. This could be like a model of, like, let's say, it could be anything. So let's say it's the number, let's say you own a shop, and let's say x is time, and then f of x is like the number of people in the shop or something. I don't know. Or it really could be anything, right? So the point is, like, we might have a question, when is the number of people in the shop equal to 10? And that's when we need to have a second person on the till and stuff like this, right? So we're interested in saying, for a particular value that we have for the input variable, like what's the value for the output variable, and just set that. So what we have with this question was f of x was equal to 0. In other words, x squared minus 5x plus 6 is equal to 0. Okay, so just to recap, we started off basically doing exactly what we did yesterday, and that was factorizing, except we set it equal to 0. And by setting it equal to 0, that meant that we could solve it and we could answer a particular question. And basically what it means is the equal to 0 is saying, like, see, if f of x is equal to 0, remember, we put the x value in, and then the number that we get out is the output. So basically they're saying, when is the output 0? Well, the output is 0 when these two values are the inputs. And then these two values, and we're calling them the roots, basically, right? They're the roots. So this is terminology, and you can always get lost in terminology. But the point about it is like, say, we care a lot about, like, this x-axis here. This x-axis, this is when y is equal to 0. So when the y is equal to 0, right? I kind of think about that as the ground, right? That's when we're on the ground. So we could say, like, when is the thing on the ground or something, or maybe it's the surface of the water. Maybe that's a better thing to think about. Imagine you had, I don't know, this is an airplane and it's going to fly like this, and you're like, okay, when is the thing going to hit the water? It's going to hit the water here and here. It's just something that we care about, and we're going to call that the roots. Okay, so that was just 15 minutes of a kind of a summary, and that's what we need to know here in this section. Okay, so let's take this picture here, right? So this U shape here, and there's a few things that we can do to this U shape. Okay, so let's say maybe we'll go to a new page for this. Okay, so we'll draw again our x and y axis. So we'll draw an x and y axis here. And let's draw our U shape. I'm just going to draw a U shape here in the air, and I'm going to make it like this. Oh, sorry, it's not what I want to do. Actually, I have a tool for this. This one, right? That one. Ugh. How do I do it the other way around? Let me turn it around, I think. Yep. I'm going to draw a nice U shape here. Okay, perfect. And let me crop that out. Okay. Okay, so this is my U shape. Let me just, okay, so let's say I have, I'm going to put down some numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, and put some numbers up here. Imagine these are the same numbers, whatever, on the axis. So let's put in our U shape. Now, it could happen that our U shape just sort of, it goes perfectly through two numbers, you see? And in this case here, this would be a root, and this would be a root. And, if we were answering the question, like if it was like, it could be x squared minus 5x plus 6, and then we would be able to factorize it using that method. And we would find, x minus 2, x minus 3. So that's obviously not what's happening here, but you see what I'm saying? We would find two whole numbers. But what happens, and this is the sort of tricky part, right? So let me just go to all of this. What happens when we get something like, so not this. So not that. Okay, what happens there is that we're not like if we have our x squared minus 5x plus 6, or I'm just doing, but if we have our quadratic equation, we're not going to be able to pick two numbers that multiply to give us, like if that last number was plus 6, we've got 1 and 6, that works, right? 2 and 3. But who would guess 1.5 and 4? Like nobody, right? When it gets to that, or 1.25, and what would that be? 5 or no, it would be 4. You know what I mean? Like, who's going to guess the in between numbers? And it might not even be a rational number. It could be an irrational number, right? So, the way a rational number might be a fraction. So it's not like you might not be able to even write it as a decimal, right? It might be some sort of repeating fraction or something like that. Okay. So that will be a kind of a problem where we won't be able to find the roots because we won't be able to use that method properly. And another problem is the following, which is also kind of interesting. You see, you can actually change the numbers. So when we have like our function, which is like, f of x is equal to ax squared plus bx plus c, okay? What these numbers a, b, and c, what they do, right, is they basically, should have done this first. What those numbers a, b, and c do for that is they basically move this thing around the place. That's all they do, right? So if that a is something, it'll, if that c is a big number, it'll move it upwards, right? And b might slide it across and stuff like this, right? So by playing around with the a, b, and c, like this will be, maybe it'll be negative numbers, one negative, one positive, both positive, and so on. And then we can get two interesting situations that come out. Our parabola can just dip down and it can just touch it in one place, and we get a double root. So that's an example of a perfect square factorization that we saw yesterday. And then another case might be it actually dips down and it doesn't cross the axis. Now, the way we're going to talk about this is that here there will be two solutions. There'll be two roots because it'll cross the axis in two places, but it doesn't cross on even numbers, so we have to use a different method to find them. Here there's one root and one solution, like a double root. And then here there's no solution. Okay. And okay, so how are we gonna handle this? So let's go to a new page. And I think once I say this, then I can get cracking through all the questions. So we're going to have to use a formula called a quadratic formula. So ax squared plus bx plus c equal to 0. And then we're going to have to use a formula like this is what it is. Minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so this is one of these formulas, it's a kind of a magic formula. No one knows where it comes from. of course, you know where it comes from. You just don't derive it. A lot of the formulas that you see on Leaving Cert that you use, you don't actually derive them. It's kind of like not a big deal to derive, it just like takes whatever, a few pages to get there. So it's just a formula. What do we use it for? If we have something like x squared minus 5x plus 6 is equal to 0, we're able to factorize it using this method. Minus 2, minus 3, right? But it's when these numbers, the a number, the number in front of the x squared, which will be the a. So a is equal to 1 here, b is equal to minus 5 here, c is equal to 6 here. So this gives us x equal 2, it gives us x equal 3. And then with this here, x is equal to then minus 5, that's 5 plus or minus the square root of minus 5 squared, which is 25, minus 4 times 1, which is a, times 6, all over 2 times 1. So this is like 5 plus or minus the square root of, well, that's 20 minus 24. So that's the square root of 1 all over 2. So it's either going to be 5 plus or minus 1 over 2. So there's two cases, which is 5 plus 1 over 2, which is equal to 6 over 2, which is equal to 3. Or it's 5 minus 1 over 2, which is 4 over 2, which is equal to 2. So we got x is equal to 2 or 3 using this method. Using this much longer method, we got the same answers, 3 and 2. Now, you would never use this method if you can use this method. Always use this method first. But the point is that we're going to have to use this method sometimes, and this is called the quadratic formula. Now, in the quadratic formula, there is this thing here, the b squared minus 4ac. And this thing here is called, it's got a fancy name, it's called the discriminant, okay? And all we have to do is think about this b squared minus 4ac. And we have to consider three cases. I'll write down this thing 3 times, b squared minus 4ac and b squared minus 4ac, okay? B squared minus 4ac greater than 0, b squared minus 4ac equal to 0, b squared minus 4ac less than 0. This first one corresponds to a parabola which crosses the axis in 2 points. Why? Because it's minus b, which is just something, a number, plus or minus. So it's minus b plus something, minus b minus something, right? Once this is a plus number, we can get the square root of it. So it'll be minus b plus a number, like it might be 4 plus 2, or 4 minus 2. See, that's the thing that gives you the 2. So if this thing is greater than 0, the discriminant is not equal to 0. So we're going to have like this thing here, either something added to it or something subtracted from it. That's what gives you the two numbers, okay? The second case is when it's equal to 0. See, when it's equal to 0, then it's like it's not there. So all you have is this one. And that's going to be the case where you get the U shape here, which comes down and touches it just there in the one spot. And that's when we're going to say a double root. And then the last case is when b squared minus 4ac, sorry, I shouldn't have done that. When b squared minus 4ac is equal to 0, or sorry, is less than 0, something kind of awkward is happening. B squared minus 4ac is less than 0. That means underneath the square root, we have a negative number, and we can't get the square root of a negative number. We can get the square root of 4 equal to plus or minus 2, because plus 2 times plus 2 gives me 4. Minus 2 times minus 2 gives me plus 4 as well. So that one makes sense. This one does not make sense. There's no real number that when multiplied by itself gives you a minus number. This is when we have to talk about imaginary numbers, and we get into complex numbers and things like this. So in that case here, when we go to graph a function like that, it'll look like this. And the question of where are the roots? Where does it cross the x-axis? That question no longer makes any sense, you see. So here we have no roots. Here we have one root, one real root, we'll call it, right? And here we have 2 real roots, right? Now, so we have no roots. Now, how can we think about this in practice? Well, if we just go back to our example, like what I was saying, like, you know, I was talking about x is time and f of x might be the number of people in the shop. And someone might say, well, when is f of x equal to 1,000,000? Right? Then it's like never. So sometimes what it means is that the question actually doesn't make sense, or so what I'm saying is that, like, if we're like, when does like we may have set up our quadratic in some way, and the question might be like, when does it cross a line? Well, the answer to the question might mean, well, it never crosses the line. It never reaches that value. It's never equal to that value. And that's what so this finding no roots is kind of like, it doesn't happen. Okay. Where this one is like, when does it cross the x-axis here and here? And when does it cross? It doesn't cross. It just touches it in one point. When does it cross the x? It never does, right? So depending on what you're modeling, the question it might be like, this is when it happens, or the answer might be it never happens. And for us, it never happening, the way in which that's manifesting in a mathematical context is like something nonsensical, like a minus number under a square root sign. Okay, so that's where this b squared minus 4ac in that formula, if it happens to be negative, that's basically like, oh, like it broke. You know, it's like when you put the numbers into the calculator and you get an error or something. It's like, no, it doesn't happen. Okay. Okay. So let's now get on with the slides. So, yep. Okay. So, so what I've done here in the first 25 minutes is to go through the additional theory stuff that happens in this section. Okay, now we can go through all the slides and we can just fly through all these slides very quickly. So just try to, keep in mind what I was saying when we go to tackle each of these problems. And if you have any questions, just throw them into the chat, and I can answer them then. Okay, so we had a question like this yesterday. We're going to have to factorize this thing in order to be able to get a solution. We're going to have to solve this thing because we have an equation. We want to get x equal to, but it's a square, so there's going to be 2x equal to, right? And what we're going to try and do in order to get there is to factorize. When we factorize, we were looking for common factors, we were looking for the difference of two squares, and then we're looking for like trinomials, where this here is the difference of two squares, x squared minus 3 squared. And I would write down an implies sign to move on to the next line. And then an implies sign, x minus 3 by x plus 3. And then we have two things multiplied by each other to give me this thing multiplied by, so there's either the first thing is equal to 0, in which case x is equal to 3. So that's my first answer. Or the second thing is equal to 0, in which case x is equal to minus 3. Okay. So I'm sort of using the implies sign when I'm rewriting an equation again with a small modification. Okay, when you have an equation, it's sort of hard to string out a whole bunch of equal signs. Sometimes you just move to the next line and it doesn't matter. But just to be neat, like if you didn't do that stuff in the exam, it wouldn't matter. The examiners can be kind of grumpy, but really don't worry about examiners. They're paid well, right? Like just it's their job to find. So if your work isn't, strictly speaking, perfectly neat, it doesn't matter. Okay, so it's just what I said there is just you can take it or leave it. Okay, so that's that one solved. So this is the solution. So when we're given this, if it's the idea is to solve it, we're going to have to come to x is equal to 3 or minus 3, for example. Okay, so here now we're going to solve this one. So when we go to solve it, well, we're going to factorize it first. Let me say implies two numbers, x and x. Okay, two numbers that multiply 1 and 12, yeah. 2 and 6, yeah. 3 and 4. And that add to give me 7, it'll be 3 and 4. And it'll be plus and plus equal to 0. And then we have two cases, either x is plus 3 is equal to 0, x plus 4 is equal to 0. And then it implies that, I say implies that x minus x is equal to minus 3, x is equal to minus 4. Okay. Now, if we were going to graph this one here, we look at the sign here. In front of the x, it's a plus. That means a U shape. We go back here, we find minus 3, we find minus 4, and then we throw a U shape over there, basically, like so. That's just a quick way to do it. And like, I may be saying things that you already are completely aware about it. I'm aware that part of this is not to say new stuff, not to say stuff that you just more looking at stuff that you already know from a slightly different perspective, maybe, and that's how you can kind of really consolidate, make sure that this is really firm footing, right? That you really understand this completely, basically. Okay. The previous one, by the way, like we could draw an XY axis, we can draw, plot our 3 minus 3 and our plus 3. and we have a plus. So this is a U shape. So it ends up being like this, right? There we go. It would look like that, okay? We don't know how low down we go. We don't know where the bottom is of this yet. We can use another technique a little later to find the bottom, but we're not going to do that today. But it gives you a quick way to get a sense of, if we sketch it, what it would look like. And this would be the sketch of f of x is equal to x squared minus 9, where x squared minus 9 equal to 0 is specifically those two values, okay? It's where does the curve, f of x is the function, where does the function cross the axis? Where does the curve cross the, where does the graph? See, we're interchanging these words quite often. Sometimes they ask you the same question in a slightly different way, right? Okay, so next one, x squared. So we'll say implies two numbers that multiply to give me 5. 1 and 5 are the only options. Two numbers that multiply to give me x. Now I need to get so it's going to have to be minus 1 and plus 5, but we don't get a minus 2 from that. And then a plus 1 and a minus 5, we don't get it. So we found that this method doesn't work. And this tells us immediately that we have to use the quadratic formula. Okay, the quadratic formula will always work, but it's longer than, you shouldn't use it unless you have to, basically. And then we have a 2a here. Okay, and we need to recover from the formula what these values a, b, and c are. So just terminology, x is going to be our variable, and the number in front of the variable, we call that a coefficient. Okay, it doesn't really matter. Terminology is just, it doesn't really matter. You have to think more about what it's doing, but if you want to talk to anybody else, that's when terminology matters, okay? So minus b, so it's minus 2, so it's 2, plus or minus the square root of minus 2 squared. Because it is square, we know it's going to be positive, so I can just say 2 squared is going to be 4, minus 4 times 1, which was a, times minus 5, and that's going to be all over 2 times a, which was 1, just going to be over 2. So this is going to be 2 plus or minus the square root of, 4 minus, so this is minus 4 times 1, it's minus 4 times minus 5. This is 4, plus sort of 20 all over 2. And then this is like 2 plus or minus the square root of 24 all over 2, which is going to be, so what I'll do with this is 2 plus or minus. Now I'm going to look at this and think, is there something in here that that I can get the square root of? And the answer to that is what's going to be, I believe it's going to be 4, isn't it? So we can say take this square root of 24 to be the square root of 4 times the square root of 6, which is going to be 2 times the square root of 6. So this would be 2 plus or minus 2 times the square root of 6 over 2, which is 1 plus or minus the square root of 6. So we have x is equal to 1 plus the square root of 6. X is equal to 1 minus the square root of 6. Now, I would leave it there, right? I wouldn't stick this into a calculator personally, but you may be asked to. So if you're doing a maths problem, we'll have a look at one up here that's on the Leaving Cert. Let's see if we can find one. Maybe I found one. I didn't find one. So sometimes you can be asked, solve this quadratic equation, correct to 2 decimal places. Okay. And in that case, we'd have to stick these into the calculator. But actually, like 1 plus the square root of 6 is neater because we don't have to round this. So we do prefer this answer in general. Also, notice that the square root of 6 is like, well, the square root of 4 is 2, and the square root of like 9 is 3. So the square root of 6 is between 2 and 3. So this is 1 plus a number that's between 2 and 3. So that's positive. 1 minus a number between 2 and 3 is going to be negative. So this is a positive and a negative root. So generally, we don't know what it looks like, but it's going to have 2 roots. One will be negative, one will be positive, and it'll be like that. Okay. So that's just an idea. Now, let's have a look at the discriminant then. So in this case here, the discriminant is 24. Okay. The discriminant is whatever number that you've got underneath the square root. It's got a funny name, but it's just a number underneath the square root. Okay. I can say discriminant, which is a word. And if you don't know that terminology, you're like, I don't know what that means. But if I say much longer, the number that's underneath the square root, it's a description. Like it depends on, you don't need to use terminology if you don't want to. The terminology is just to say things more short. But if you can describe what it is, that's much better, right? It's just not much better for talking to anyone else about it, right? So the number that's underneath the square root is the discriminant. Remember, if it's greater than 0, we've got 2 real roots. If it's equal to 0, we have 1 root that's repeated. If it's less than 0, then we have no real roots. Here, it's the square root of 24. 24 is greater than 0, so we are in the first case, okay? The first case, that one. Okay, so this one is factorizable, so I don't think we need to do this. I mean, I can do it super fast. Brackets, x, 2 and 3, plus and plus equal to 0. It might be a little counterintuitive, but the root is always the opposite sign. Like if this is a 2 here, a plus number, the roots of this one here, when we graph the xy axis, it's over on this side. There are 2 negative roots. Slightly counterintuitive. This one here, okay, so we have, let's see what we get. So we just factorize x and x, 3 and 1, like -3 and +1. So those two would multiply to give me a -3, and they would add to give us a -2 equal to 0. I remember to write my implies. X is equal to -1, x is equal to 3. So if we go to graph them, we have the -1 and the 3. And the reason why I wrote the formula here is that we could find the -1 and the 3 using the quadratic formula. It's just that we wouldn't, because it would be longer, okay? The rule is if you have like longer expressions with more and more minus signs, like you just make a mistake with a minus sign and then you go wrong, okay? So you kind of want to avoid that if you can. Yes. Okay, so we want to graph this one here, and we also want to find the discriminant. So let's just have a look at that expression. First of all, what we're going to do is we realize this is a plus number here. This is a U shape. In order to graph it, we need the 2 roots, okay? So we're going to set this equal to 0 to get the 2 roots. X and x, 2 numbers that multiply to give us +4 and add to give minus. So this is -2 and -2. That will work. And it's actually a perfect square, isn't it? So that's either x -2 is equal to 0 or x -2 is equal to 0, which just tells us that x is equal to 2. The second one tells us the same thing. So we just have a single root. Now, if we go ahead and look at the discriminant here, so this will be our a is equal to 1, b is equal to -4, c is equal to 4. Okay, we have our formula x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is whatever is under the square root. It's b squared minus 4ac. Let's have a look at what that's equal to. That's b squared. B is -4. -4 squared is 16. -4 times 1, which is a, and 4, which is c. So that's 16. And this is -16 is equal to 0. So the fact that the discriminant was equal to 0 meant that we had that double root. When the discriminant, sorry, I didn't mention this, this triangle symbol is a way of saying the discriminant in maths. Okay, so what we're doing with all the symbols and stuff that we use in maths, the reason why we start to use like Greek letters and in the alphabet you've only got 26 letters, right? And then you can write words, but there's just like lots of letters. But if we start to use the Greek alphabet or other symbols, then we can just have a single symbol representing a word or a concept, okay? So that's why we have these funny symbols is basically so we have to write less, okay? We don't have to write words. Like we would never write discriminant is equal to that. It's all about, maths is all about making things shorter, right? Okay, so that triangle symbol means the discriminant here. The discriminant is greater than 0, 2 real roots. The discriminant is equal to 0, one root. So this one then that we found, x is equal to 2, that will mean that we have a U-shaped graph. We go 1, we go to 2, and now we have a graph that goes down and just touches that there in 1 point and goes back up. Okay. Sorry, let me just do that again. Like that. Okay, so this is probably where we're going to find, so we'll try to factorize this one now. X and X, two numbers that multiply to give me 5, 1 and 5 are minus 1. We can't get the 2 from that, so we're going to say use a quadratic formula, minus b plus or minus the square root of b squared minus 4ac all over 2a. What's my a? My a is equal to 1, my b is equal to 2, my c is equal to 5. So now I'm going to say, let's have a look at the discriminant first. So the discriminant is b squared minus 4ac, which is b squared 4, which is like 2 squared, minus 4 times a, which is 1 times 5. That's 4 minus 20. It's minus 16. The discriminant is less than 0, which means that there's no discriminant is less than 0, no real roots. Okay, now what happens with this formula? We're going to see, so we have minus 2 plus or minus the square root of b squared 4 minus 20, right? We already knew that it was 16. Okay, so we all over 2, or 2 times a, which is 2 times 1. This is minus 2 plus or minus, sorry, that was a minus 16, sorry. The square root, so this is the square root of 16 times the square root of minus 1, all over 2. And that ends up being minus 2 plus or minus 4 times the square root of minus 1, all over 2. It ends up being minus 1 plus or minus 2 times the square root of minus 1. So notice what I've done. This minus underneath, this minus sign here, like is causing lots of problems, that minus sign there, right? So, but I've still gone ahead and separated out. See that bit with the minus side, I've actually just separated that piece out. I can't handle it. I can't do anything with it. But I've gone and done everything else that I possibly could do. It's sort of like, I don't know, like it's like the exception to the rule or something. It's like, I don't know, if you're tidying up in your house and everything goes in its own place, but you just got one random thing and you've got no category to put, it's not closed, it's not something you can put into any drawer. It's just like a random, you just sort of put it to the side and deal with it later. And now we've gotten down to the end where like this is our answer, minus 1 plus or minus 2 times the square. What we do then is you put the square root of minus 1. We just give it a funny name, I. And the reason why we give it I is because we don't want to write down the square root of minus 1 because we want to be able to write. So this answer is then minus 1 plus or minus 2i. And this gives us x is equal to minus 1 plus 2i, x is equal to minus 1 minus 2i. And these are complex numbers, okay? We'll talk about them another time. It doesn't matter. Basically, I is this is a real number because it doesn't have I in it, just a real number. This second number here is called an imaginary number because it's just a real number multiplied by I. So they're two different sets of numbers. They're real numbers and imaginary numbers. And when you combine a real number and an imaginary number together, you get what's called a complex numbers. Complex numbers are useful in some circumstances. In particular, they're useful in situations where things rotate. Okay, so anything that moves around in a circle, you'll find that complex numbers are useful to describe this type of behavior. Don't need to know that, but the point about it is that we don't do anything in the maths course that isn't used at some time, in some case, in engineering and computing or something. It's useful at some point in the future. You sort of, but they don't tell you applications, right? Okay, great. So quick quiz, maybe just take a minute to go through a couple of these examples, and then I think I can give you a small quick look at a few exam questions. We're not going to do we're not going to concentrate on too many on exam questions, but I just want to give you a little hint of what's to come and how you can use what we've been talking here in like on the actual exam, right? So it's the exam is always a little bit further than what you do in class, what you do in the book, but just to show you that there's that connection there. So just take a minute or two to just have a go at these examples. Okay, so let's have a go. So we'll just answer each of these. So we're going to solve them. First, factorizing. We have for the first one, brackets, x and x. Two numbers that multiply to give me 8. 1 and 8. Can't get the 6 from that. 2 and 4. Yeah, adding will work. X plus and plus. And then you can jump right to the last line. X is equal to -2. X is equal to -4. Now, this jump here is equivalent, like, remember I was talking about this yesterday, like going up a set of steps, right? If you go one step at a time, you'll never fall over. If you try to jump steps, like jump 2 steps, jump 3 steps, you'll probably be okay. But this is the time when you fall on your face, right? So here, like if you feel very confident, you don't have to write down the line x plus 2 is equal to 0 and x plus 4 is equal to 0 and then go over, but just to flag that for you. This like it saves a little bit of time, but not too much, right? Okay, second one, and this is equal to 0. So factorize on the left-hand side, then set it equal to the right-hand side, and then that's what allows us to solve. This would be a quadratic that would go through the numbers -2. So there's -4, -2 would be like that. Okay, this is the difference of two squares. So x squared minus 4 squared, which is then equal to x minus 4 times x plus 4. That's equal to 0. And that implies that x is equal to 4 and x is equal to -4. I like to say that like maths is the only way sort of writing. That's as fast as you speak. That's why it's all of these symbols and stuff. Okay. Okay, so we do this one. It says already for us that the formula is needed. So this is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to go in here and write down, well, a is equal to 1, b is equal to -4, c is equal to 1. So this is like minus b minus -4 is going to be 4 plus or minus the square root of 16 minus 4 times a times c minus 4 all over 2 times 1, which would be, so that'll be 4 plus or minus the square root of 12 all over 2. So that'll be like 4 plus or minus, well, that'll be like 2 times the square root of 3 all over 2. So that'll be 2 plus or minus the square root of 3. So 2 plus the square root of 3, that's one value, and the other value is x is equal to 2 minus the square root of 3. Okay, perfect. And then the last one, they're not saying about, they just want us to find the discriminant to predict the number of real roots. Okay, so what am I going to do? Let's say this is a is equal to 1. This is b is equal to 4. This is c is equal to 8. And I'm going to use this formula, but I'm only going to use the discriminant, which is this piece, b squared minus 4ac. This is the discriminant. And for us, b squared minus 4ac is going to be 4 squared, which will be 16, because it's 4 squared, minus 4 times 1 times 8. This is going to be 16 minus 32. It's going to be minus 16. The discriminant is less than 0, so no real roots. This is a quadratic equation, which is hovering up in the air above the x-axis. The question of where it crosses the x-axis, in other words, what are the roots, does not make any sense. Okay. There is nowhere where it crosses the axis. There's no real number where it crosses the. I got an answer last time. There are complex numbers where, but you know what I mean? This is when we get into another subject. So we're not going to, in a sense, if you consider complex numbers, it does cross the axis, but we're not dealing with complex numbers. We're dealing with real numbers. There is no real roots for this. Okay. Okay, great. So we have another couple of minutes. I have the next class is starting in 8 minutes, so I've just got enough time to go through a couple of examples here. We'll see how far we get before we have to stop. Okay, so here it says that x minus b. They're saying find the value of b. So what they've given us first is like they've given us a quadratic equation. There's a few things that's off. Like I've been saying, like f of x is equal to something like x squared plus 5x plus 6 or something. So I've been using f for function every time. This has got a h. Is there any significance to that? And the other thing is that we've never had a situation where we didn't know what the coefficients were, right? We always knew what our a, b, and c was. Here, we haven't been given that one. So these are the two differences. So okay, now we see what's different about this question. Now let's consider these two things in turn, okay? Not at the same time. Let's just break this down. First of all, this question of using a h. Is there something like, I've been saying f for function, f of x is equal to stuff. What if I say h of x? Am I meaning something else? No. So you just, if they use a h, g, p, none of that matters. Okay. It's sort of weird what happens, but we get kind of married to the idea that everything always must be f and everything must always be x. They could be p of y or m of n. It's kind of weird to be able to solve these ones because it's sort of like doesn't look familiar, but like the letters are not important is what I'm trying to say. Okay, fine. The second case, it's like, yeah, this makes a difference. And we have to approach this we have to be a little bit more intelligent in the way that we approach this. So let's have a look at what they're saying. They're saying find b if x minus 4 is a factor. Now, we've already talked about the factor theorem. We've already talked about this like right at the start of this thing. So if here we were like, find the roots and all this sort of stuff here. Basically, once we found a factor like x minus 2, we could find the root directly from that. Okay, so x minus 2 is a factor, x equals 2 is a root, x minus 3 is a factor, x equals 3 is a root. So let's go back to this question here. This is on the leaving cert. If x minus 4 is a factor, implies x is equal to 4 is a root. Now, what does that mean? See, it's asking you completely backwards. If it's a root, h of 4 equals 0. Because it's going to, let's graph h. This is the graph of h. I don't know what h looks like. Let's say this is what h is. It'll look like this. It'll be a U shape because it's a plus number in front of the x word. So that means a U-shaped parabola that goes through the number 4. That will what it mean. It would be what if x minus 4 is a factor, x equals 4 is a root. That means that the function goes through the number 4. Okay, so that means that h of 4, which is, see, h is the graph, right? Which is this parabola. H of 4 equals 0. See, h is also this axis. You see, basically what it's saying is like as we go along the thing here, when do we reach the 0 value on this axis? It's there and there. So if x equals 4 as a root, that means that h is 4 is equal to 0. You have to be able to do this, in this direction or in this direction, right? So you have to be able to connect all these ideas all together. Okay, so that means that we can say h of 4, which is equal to 4 squared plus b times 4 minus 12. This is going to be 16 plus 4b minus 12 is equal to 0. And then if we say, well, that's 16 minus 12 is 4 plus 4b is equal to 0, that's going to say that b is equal to minus 1. So they're saying, see where they find the value of b for which x minus 4 is a factor of h of x. If b is equal, so we can say if b is equal to minus 1, then it means that x minus 4 is a factor of h of x because x equals 4 would be a root then, and then if we were to sub the 4 in, we would get that equals 0 bit that's coming out of it, okay? So it's basically like jumbled up, right? Normally the questions you get from the book are more straightforward than that. And if we look at the marking scheme here, like this, there's a couple of methods that you can use, but if we look at this first method here, we've got 0 marks, we've got top marks, 10 marks. What about the low partial credit, which is the 4 marks? Basically, work of merit, for example, if you say, so if you go from x minus 4 to simply saying that x is equal to 4, you get 4 marks out of 10. Now, you might not have any clue how to do this question, and you might look at this question, and you might say, I am never getting the 10 out of 10, but you absolutely must not get a 0 out of 10 then. You have to get whatever marks that you can. So that is probably the most important thing that I'll say to you. If you don't know how to do a question, it does not mean 0 marks. It means you have to get some of the partial credits. Okay, so just, you might not know what to do, but do something that makes sense, do something sensible, do something that you think, try something out. You probably end up getting 4. And if you got that on every single question, then you would pass the test, right? So this is where we are. Okay, one more quick one. Now, this one here says, explain why the following equation has no real roots. Now, we talked about this yesterday. This thing has already been factorized somewhat for us. Well, like, let's take the number 24. 24 could be written as, I think it's 2 by 2 by 2 by 2 by 3, I think it is. Is it? Yes, it is, right. So that's 24 factorized, but we could write 24 as like 10 plus 14, so that's 2 times 5 plus 2 times 7. So this is another sort of version of it being factorized, but it's not useful to us. So what we'd have to do is, if we were given that, we'd have to get back to the 24 so we can go down from the 24. So we have to go back up and back down again. What does all that mean? Just multiply this thing out. 2x plus 3 all squared plus the 7. This will be 2x plus 3 times the 2x plus 3 plus the 7. Now I'm going to multiply out this 2x by 2x, 2x by 3, 3 by 2x, and 3 by 3. So that gives me 4x squared plus 6x plus 6x plus 9 plus 7. This is 4x squared plus 12x plus 16. This is all equal to 0. See, it's a little bit messy. Always when you do maths, you're a little bit messy. Now we'll have a look at this thing here. A is equal to 4, B is equal to 12, C is equal to 16. A big positive C is always a bit of a warning sign. The discriminant is B squared minus 4AC. Here, that's equal to B squared, 144, minus 4 times A times 4 times C, which is like 16. I should have divided through by 4, shouldn't I? Let me just do that quickly. That's the same as x squared plus 3x plus 4 equal to 0. That's a lot easier, isn't it? A is equal to 1, B is equal to 3, C is equal to 4. This is exactly equivalent to that. The discriminant is going to be B squared minus 4AC. So that's going to be 3 squared minus 4 times 1 times 4. That's going to be 9 minus 16. That's going to be minus 7. See, it's negative. It's less than 0. So that's why it has no real solution, okay? And then again, we have our marking scheme. So a work of merit would have been sort of like, you just mentioned this b squared minus 4ac is less than 0. Or if you did some work, like if we did even just if we did just that piece, 4x squared, writing that out will get you 2 marks out of 5, which might not seem much, but that's 40%. If you do the everyday question, you'll pass, okay? So just be aware of those things. Okay, I've got to go. The next class is on. So just as a quick, this is what we were solving quadratics. We're finding when y is equal to 0. Factorizing as fast as when possible, but the formula always works. And then the discriminant will predict the number of the roots, whether or not it's too positive or too negative. So, okay, so I hope that was helpful. I'll send on a few test questions later, and then a link to this thing as well. You can share it around. There's lots of place in this. If you have anyone who's interested, you can let them know, just send a link or whatever. And yeah, I'll see you tomorrow then at 4:30. Okay, thanks.